Hello and welcome. In this lesson, we are going to take on the PWM pins of the ESP board. All 36 of the ESP32 general purpose input-output pins has a PWM capability. This is a really great thing, but we must use more complex code to reach the same result on other pins. So let's program one of the general purpose input-output with a PWM output signal. Now, if you went to this schematic or this pin out for the ESP board, you can see that all of these pins can be used to generate PWM signals. The first thing that you need to think about when programming a PWM signal is its frequency. You need to generate that signal at a certain or a specific frequency. We will use a value of 5000 Hz. That works fine with our LED. We must also specify the LED PWM channel and the resolution of the PWM duty cycle. I won't explain the PWM because you must have some basic knowledge about PWM signals, but what it takes is a resolution, a channel, and a frequency. So after specifying the duty cycle using the resolution and the frequency and the channel, we can start programming. We can choose a channel from 0 to 15 and a resolution between 1 and 16 bits. We will use channel 0 and a resolution of 8 bits. So let's get started. Let's go to coding, create a new sketch. And here in our new sketch, let's define some variables. First, we need to define the frequency. Int frequency, and let's make it 5000. Then we need the LED channel. Let's make it 0. And we need the resolution. And let's make it 8. Now, let's use the general purpose input-output pin number 2, where we have our LED or our external LED connected or attached. It also has a built-in LED that can be used. So these parameters must be defined inside the setup function. So let's go and write this code. Now, what we are going to write inside the setup function won't be something we are used to. We are going to write LED-C attach pin and LED-C setup. Now, the LED-C attach pin and LED-C setup, they are basically functions for the PWM configuration. They are very similar to analog write function in Arduino. So now the ESP doesn't support the analog write function, but it does support a much better one, which is the one that we already mentioned, LED-C write. The LED-C write function is very similar to analog write. It also requires two parameters: the PWM channel that we want to write a value to, and the PWM value we want to write to the selected channel. Now, let's first finish the setup function. Now, the LED-C setup function will take three parameters. The first one will be the LED channel. The second one will be the frequency. The third one will be the resolution, which we already defined up there. Next, we are going to assign a LED to that channel. So LED-C attach pin. Now, the LED pin we already chose is 2, and we want to attach it to the LED channel that we have chosen. This is it. This is how you finish setting up the PWM frequency, resolution, and channel, and how you can attach it to any output pin. Now, to turn on the LED, which is connected to pin number 2, using the LED channel output from the PWM signal, we need to set a specific brightness. Now to turn the LED on or off, we must define the duty cycle. For example, to turn off the LED, the duty cycle must be 0, and the function LED_C_right that we already mentioned can be used inside the loop to set the brightness to 0. Now, we can use that function right now. Let's write LED_C_right. It's exactly like analog write, and it takes two parameters. The first one is the LED channel, which is this variable, and the second one is the duty cycle. Now you can add in duty cycle here and add 0. This will turn off the LED because we have sent 0 to the LED channel, which is pin number 2, and it will set the brightness to 0. Now, different values of the duty cycle will turn on the LED with different brightness. Now, this variable can be from 0 up to 255. Once the resolution used is 8 bits. If we used a 10-bit resolution, it can go from 0 up to 1024 or 1023, and so on. We already mentioned that you can choose a resolution between 1 and up to 16. So the choice is yours, but you need to make sure that you are choosing a duty cycle that matches your resolution. So in 8-bit resolution, the duty cycle will be between 0 and 255. Okay, now that we are done with this, we can use the potentiometer connected to the analog pin from the previous lesson to control the brightness of that LED, or we can simply send values. Now, to test this out, let's complete the code. Let's first, in the setup menu, add serial.begin and choose a baud rate 115,200. Then add a delay as usual for 1 second. After that delay, let's write a sentence to make sure that everything is working correctly. Print line, and let's name it testing PWM. Okay, now we have the LED setup and the LED_C attached pin, and we can use the LED_C_right up here, and the first value that will be written is 0, so the LED will be off. Now inside the void loop, we can send other values. We can send duty cycle. Let's define duty cycle here. Plus equal +1, and let's add a delay. Let's make it 15 milliseconds. Okay. Now, let's move this line down here. It will start with 0, then it will be +1, or let's make it +10, and we'll keep moving until it reaches 255. We can add an if statement, but let's test this code out. Let's first upload the code or verify it to make sure that it doesn't have any errors. Let's save it. PWM testing. Okay, done compiling. Now let's upload the code. Okay, we should add a line to make sure that we will print the duty cycle. We will recompile the code, but for now let's recompile it so that we can get the duty cycle here. Now let's recompile the code, verify it again. Now let's upload it. Okay, now as you can see, it went above 255 very fast, so we need to control this. Once the duty cycle reaches, duty cycle is above or equal 255, we need it to reset to 0. Now let's compile it again. Now let's upload it. Okay, done. Now as you can see, once it reaches 255, it resets to 0, and from your ESP board you can see that the built-in LED or the external LED that you are connecting is fading in and out using this very simple code. Now let's summarize what we did in this lesson. We have set the frequency to 5000, we have chosen LED channel to be 0, and we have chosen the resolution to be 8, which means that we have duty cycle between 0 and 255. We started with a duty cycle of 0, and here we initialized the serial communication. Here we used new functions, LED-C setup, to set up the PWM frequency, channel, and resolution, and this LED-C attach pin to attach the PWM function to assign to a specific pin, which is pin number 2 here. And the LCD write is basically like analog write. It takes the channel and the duty cycle and it writes a value to that channel. Now in this void loop we have used the LED channel, which we already attached here to pin number 2, and the duty cycle, and we kept increasing the duty cycle by 10 and print it on the serial monitor. Now once the duty cycle reaches 255, which is the limit here, we did reset the duty cycle to 0 to repeat the process again, and that is how you can fade a LED using PWM signal. You can apply this to any other thing. You can choose 10-bit resolution. In that case, if you did choose 10-bit resolution, you will get values between 0 and 1023. So in that case, this if statement will be 1023 instead of 255. That's it. I know that this was a long lesson, but I wanted to explain PWM using an example. I hope that everything is now well explained to you. If you have any question regarding anything, you can ask. This is Ashraf. See you next lesson. Happy learning. This is Educational Engineering Team.